Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudewa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 3 on vertical projectile motion, and then we are given 3.1. It says ball A is projected vertically upward at a velocity of 10 meters per second from the ground as shown in the diagram below. And then down the diagram, they say ignore the effect of air resistance, use the ground as zero reference. Then 3.1.1 says explain the term projectile. So we know the definitions that we have to expect under VPM. It's either projectile or free fall. So make sure that you don't walk into the exam without knowing those two definitions. Okay, so what is a projectile? We say this is an object which has been given an initial velocity and moves under the influence of the gravitational force only, of the gravitational force only. Right. So that's it. It's an object which has been given an initial velocity and moves under the influence of the gravitational force only. So that's your projectile. Right. And then now let's move to 3.1.2. It says draw a labeled free body diagram indicating all the forces acting on ball A just before it reaches the maximum height. And then we can see we are given 1 mark there. And then according to our definition here, this should be obvious. Remember, it's moving under the influence of the gravitational force only. So that means the only force acting on this object here would have to be the gravitational force. So you just indicate your dot here to represent the ball, and then down you have FG. So that's all you need to draw. Right. Then for 3.1.3, they say write down the magnitude of ball A's kinetic energy at its maximum height. Now, this is a key word. We know that at the maximum height, the velocity is equals to 0 meters per second. And then since we know that our kinetic energy is a product, it's half a product of the mass and v squared. We know that if the velocity is 0, then obviously our EK has to be 0 joules. So for 3.1.3, the magnitude of the kinetics energy at the maximum height is 0 joules because the velocity is also 0 there. So if there is no movement, then there is no kinetic energy. Okay, now let's check. So we still have 3.2. It says 0.5 seconds after ball A is projected upwards, and then a second ball B is dropped from point P, which is 8 meters above the ground as shown in the diagram below. Then 3.2.1 says calculate the time it takes for the ball to reach its maximum height. This is a 3-mark question, and then as we know with 3-mark questions, it's just simply the correct equation of motion and then substitution into that correct equation of motion and then the answer. Right, so now collecting our data for ball A. Now, since ball A is being projected upward, I will just choose to take upward as positive, right? So I will choose to take upward as positive. Now it is your choice. If you go with downward as positive, you should know the conditions under downward as positive. So my A will have to be negative 9.8 meters per second square if we are taking upward as positive, and then my VI, I'm given that it is 10 meters per second, so I will write it as a positive because I'm taking upward as a positive. Then calculate what the time to reach its maximum height. We know that at the maximum height, the final velocity would have to be 0 meters per second. right? So we are looking for delta t. Now, which equation of motion do we have to use with the data that we have collected here? So you see how it goes. First, collect the data, and the data will lead you to the correct formula that you need to use, right? So always do it with that approach. Now, this is Vf is equals to Vi plus a delta t. Perfect formula for this. We don't have delta h. We don't have delta y, which is the distance, because we don't know at what height will be the maximum height. Remember, we are just given that the distance from here up until point P is 8 meters, but then we are not given that the 8 meters is the maximum height. So we don't have delta y. And then, okay, Vf is 0, and then Vi is 10, and then here we have negative 9.8. Then we are looking for our delta t. Now we can take this one and transpose it over to this side. We have 9.8 delta t is equals to 10. And then if we can divide both sides by 9.8, then our delta t would have to be equals to 1.02 seconds. So the time it takes ball A to reach its maximum height is 1.02 seconds. Okay, so 3.2.2 says calculate the time at which ball B meets ball A. The time at which ball A meets ball B, right? So now when it comes to this, let's understand. Now we want the time, right? We are looking for the time t where ball B will meet ball A. So this is what happens. Let's say hypothetically when we drop ball B somewhere here, this is where it meets with ball A. So at that particular point, we don't know the height, right? But then one thing that we know is that at the point where they will meet, they will have the same height above the ground, right? So the height above the ground of ball A and ball B will be the same at the point where they're at the same position, right? So that's what we know. So that means in this case, we can choose an equation of motion whereby we can equate the delta y's, right? So now let's start. If we are indicating ball A, remember I've already chosen upward as positive. So once I've chosen upward as positive in this question here, then throughout the whole question, I must use upward as positive. So my A as a result will be negative 9.8 meters per second. Now delta Y I do not have, right? But then I will make it the subject of the formula since I've established that at the point where they will meet, they will have the same height above the ground. So, okay, now this is A, this is delta Y, and then my V initial is still 10. Note that this is for ball A, 10 meters per second. And then we are not concerned about the VF here because we don't know the final velocity at the point where they will meet, right? So ball A, now which air formula can we use? Remember, we are looking for delta T. So the formula that we can use is delta Y is equals to Vi delta T plus half A delta T squared. So we are looking for all the formulas that do not have VF, right? Because we are not concerned about VF. So now this is the correct formula to use. So delta Y is we will write it as Y of A. And then what's my Vi? It's 10. My delta T, let me just substitute it as T because we don't know the time at that point, plus half, and then 9.8. And then here I have T squared. So this will be YA. So pardon me there, this is negative 9.8. So this is Y1 is equals to 10T minus 4.9 T squared. Let me call this equation 1. Okay, then done with ball A, let me go to ball B. Now, ball B, note that it is dropped, right? Again, with the same formula, delta Y is equals to Vi delta T plus half A delta T squared. Let's try to find the data for ball B. So the V initial is 0 because remember it is being dropped. Dropped is a keyword to say the initial velocity will be 0. And then what is our delta Y? we do not know, but then we'll make it the subject of the formula. So this will go as YB. And then what's our delta T? Now, remember that ball B is dropped 0.5 seconds after ball B has been projected upward. So it has to be T minus 0.5, right? Why T minus 0.5? We are considering that it was dropped 0.5 seconds after. So the time that ball B will travel is 0.5 seconds shorter than the one that ball A travels at the point where they are at the same position, right? Okay, so now we have all that, and still my acceleration. Remember, once I choose upward as positive, whether the ball is going upward or downward, my acceleration will forever remain negative 9.8 meters per second square, right? So your direction of motion, what you choose as your direction of motion determines what your value of A will be. It's not a matter of whether it's moving upward or downward. If you choose upward as positive, it is always negative 9.8. If you choose downward as positive, it is always positive 9.8. So always get that into your head. Then delta Y, we have YB is equals to VI is 0. Delta T, we represent it as T minus 0.5. And then plus half, this is a negative 9.8. And then T minus 0.5 square. Now, all of this will fall off because 0 multiplied by any number of variable is just 0. So we'll end up having YB is equals to negative 4.9. And then here we have T square minus T and then plus 0.25. So if I were to FOIL this, so if you do your math, you'll end up with that. Then your YB will just be negative 4.9 T square plus 4.9 T. And then here, I have a minus negative 4.9 times 0.25. That has to give me negative 1.225, right? So let me call this equation 2, right? But then now, remember we said at the point where they meet there, they would have to have the same height above the ground. But note that the direction of motion is not the same. B is going downward and A is going upward. So we have to be smart in the way we do this. So if this length here, let's say this length from here all the way up until here represents YA, right? And then going that direction. Then what is the height of B above the ground if it's coming from this direction? Now note that our YB is this, right? So let me indicate with a different color so that you understand. So this would have to be YB, right? This is YB, right? But then if we want to determine that A and B are equal above the ground, then I would have to write YB in a different format. I would have to say, I have this whole 8 here, and then how can I write it in a way that it will be equal to this? So let's say, for example, this was 3 meters, and then this is 5 meters. Now we can see that YA and YB, they are not equal. But if I want them to be equal, then I have to change my point of reference. So that means I would have to say, I say 8 minus YB. Now you get to understand that that is similar to what? To YA, right? But then again, let's consider the fact that I chose upward as positive. Upward as positive. Now, if my upward is positive, what does it mean? It means that here, my YB would have to be what? Would have to be negative, right? So my YB would have to be negative because I chose upward as positive, but ball B is going downward. So that means my delta Y has to be negative. So that means I have to come here and say this is similar to saying Y minus negative YB, which then will give us 8 plus YB is equals to YA. Right. Now, once we have that, we can then solve this. Now, remember, now we have an equation. Y plus YB is equals to YA. So what can we do now? Plus, what's YB? The equation for YB, it's all of this, right? So that's 8 plus negative 4.9 t square plus 4.9 t minus 1.225 is equals to YA, which is 10 t minus 4.9 t square, right? Then we can take all this and bring it over to this side. Then this is going to give us a negative 4.9 t square. Now, obviously, let me just do this. We know that the negative 4.9t will cancel out with that negative 4.9t, because when it comes over here, it will be a positive. And then now we'll be having 4.9t minus 10t. And then this will be plus 8 minus 1.225 is equals to 0. And then at this point, we can then say we have 4.9 minus, so 4.9 minus 10, that's going to give us negative 5.1, and then t. And then if we say 8 minus 1.225, that's going to give us 6.775, which if we transpose, it's negative 6.775. And then if we divide both sides by 5.1, negative 5.1, negative 5.1, then our t has to be, divide that by 5.1, our t has to be 1.33 seconds, rounded off to 2 decimal places. Okay, so that's it. That's how you were supposed to go about answering that question. So the only tricky part was having to come up with this equation here so that you can be able to equate your expressions here and finally get your value for t. So consider those things about when you are choosing upward as positive, then how should be your delta y in terms of the movement of the ball, if it's going upward or downward, right? Okay, and then let's now move to 3.2.3. So this was supposed to be 3.2.3. Okay, now let's get to 3.2.3. It says on the same set of axes, draw a position versus time graph for ball A and ball B, indicating the whole motion until the instant the two balls meet. Use the ground as reference. Take upward as positive, right? So we are told to take upward as positive. Then they say clearly show the following on your graph: initial position of the two balls, the time at which the balls meet. Okay, so now we will start with our Cartesian plane. And then we are to take upward as positive. So that means we draw it up here on the positive y-axis. Then let's start with ball A. Ball A starts from the ground, right? So it starts at 0 position. They said we must take this as the ground, right? So your ball A goes all the way up like that, reaches the maximum height. And then at the point where it reaches the maximum height, what was the time? The time was 1.02 seconds. We did calculate it in 3.2.1. And then after reaching the maximum height, on its way down, it then meets with ball A. And then at the time was 1.33 seconds. So that's it. And then let's indicate this is ball A. Okay. Then what happens to ball B? Ball B starts 0.5 seconds late. So let's indicate this is ball B. So at 0.5 seconds, ball B is dropped. Ball B is dropped. So at a height of what? 8 meters. And then there is our ball B. Goes down like that up until the point it meets with ball A. Right. So at that point, that's the point where they meet. So we were not told to calculate the height at which they met. So we'll just leave it like that. And then that's it. So let's indicate this is ball B. So that's how your position time graph was supposed to look like. So this is time in seconds, and this is position in meters. Okay, so something like that. And then that's how you were supposed to go about answering this question for a total of 14 marks. So make sure you revise your vertical projectile motion and just make sure that those marks are always in the bag. So with all that being said, guys, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit the subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.